This is the fourth problem. Fr is given to you. Then show that line integral fr dot dr bar is equal to 2 pi, where C is the circle with center at origin. Here, vector point function fr, which is defined on the circle. We want integral of fr dot dr bar. Fr is what? Minus y by x square plus y square I plus x by x square plus y square j dot dr bar. Dr bar is what? dxi plus dyj plus dzk. R bar is xi plus yj plus zk. That is position vector of any point on the curve here on the circle with reference to the origin. Now the dot product of these two, coefficient of I multiplied by coefficient of I, minus y dx by x square plus y square, coefficient of j multiplied by coefficient of j x dy by x square plus y square, and k is not there. This coefficient of k is 0, 0 multiplied by dz will be, is no need to write. Now this integral I am evaluating on the circle C, and the radius of the circle, and the radius of the circle is what? Not known, but center is 0, 0. The circle is like this, equation of the circle, x square plus y square is equal to r square. Center of the circle is 0, 0, and radius of the circle is not given. This integral I am evaluating on this circle. C is the circle. The parametric equation of the circle, x equal to r cos theta, y equals r sin theta, x square plus y square is r square, because when you square it and if you add, you will get this relation, and dx is required in the differential of x. Dx is required. This r is r, derivative of cos theta is minus sin theta d theta, and dy is r cos theta d theta. R is the radius and it is constant. Now integral over C minus y dx minus y r sin theta dx is what? Minus r sin theta d theta. X square plus y square is r square. Here x r means r cos theta, dy is r cos theta d theta. X square plus r square is y square is r square. Now this r square gets cancelled with this r square. This r square gets cancelled with r square. Here sin is minus plus, sin into sin is sin square theta, plus cos into cos is cos square theta, and d theta is 1. The sin square theta plus cos square theta is 1. In a circle, theta varies from 0 to 2 pi. Here theta varies from 0 to 2 pi. An integral of 1 with respect to theta is theta, lower limit 0, upper limit 2 pi, and put theta equal to 2 pi, upper limit, put theta equal to 0, lower limit. In this way we have proved. Just very quickly, the next problem now, integral fr dot dr bar is a work done. But when it is work done, where fr is a force field, find the work done in moving a particle from 0, 1, minus 1 to pi by 2 x coordinate minus 1 and 2 in a force field fr equals y square cos x plus z cube I 2y sin x minus 4j and 3x z square plus 2k. And one more question is asked, is the field conservative? Yes, find the work done in moving the particle from this point to this point in a force field, Fr is given. Is the force field conservative? So when the force field is conservative, if Fr is this force field is written in terms of gradient of scalar point function, then Fr is conservative. And here del cross of Fr and del cross del phi, curl of gradient of phi is 0. If del cross Fr is 0, then you can say it is conservative. In conservative field, line integral from this point to this point through curve C, line integral from this point to this point through this straight line, line integral from this point to this point through this curve C1. The value of the line integral are different. The work done is different. Okay, no doubt the particle due to force, the particle is being displayed from this point to this point. The particle is being displayed through this curve, through this line or through this curve. The line integral value will be different. The work done will be different. But when the force field is conservative, then the line integral is independent of path. Independent of path. Line integral is independent of path. Means what? What is the meaning of it? Value of line integral through any path will be same. Work done is integral Fr dot dr. Dr bar is dxi plus dyj plus dz. The F bar dot dr bar is what? For y square cos x plus z cube dx. 2y sin x minus 4 dy and 3x z square plus 2 dz. This multiplied by this multiplied by this, and coefficient of k multiplied by coefficient of k. This is Fr dot dr. So what I am going to do here in this problem, conservative concept is asked. And if you look at this function very carefully, so what I am going to do is I am going to split it up. Y square cos x dx, z cube dx plus 2y dy, 2y sin x, sin x dy minus 4 dy, 3x z square dz and 2 dz. Which is I have distributed dx, dy and dz. So if you look at these two terms, it is derivative of y square and sin x. Y square into sin x. So you can resolve it by producting. First function y square, derivative of sin x is sin x dx plus second function sin x and derivative of 2y is 2y dy. Now y square cos x dx, this term is there. 2y dy sin x, 2y dy sin x, this term is there. These two terms can be written as derivative of y square sin x. See, if you look at these two terms, this term and this term, so this is what? Derivative of x z cube. What is derivative of x z cube? First function by product. 3z square dz, derivative of z cube. Z cube and derivative of x is dx. Okay, this x cube dx, 3x z square dz, 3x z square, this term is also there. This can be written derivative of z cube. Means derivative of first group, this term, derivative of this term, and what is remaining now? What is remaining? Minus 4 dy is remaining and plus 2 dz is remaining. Is derivative of y square sin x z cube minus y, 4 is constant, y is derivative of y dy, and here 2, derivative of z is with this function I have written in d of phi. d of phi is a scalar point function. To write down in this way, integral of d phi, so that value is, yes, you can write down here a and b, lower limit, upper limit, here a and b, and after integration a and b like this. Here, this component is phi. So this I am writing a function y square sin x plus x z cube minus 4y plus 2z, and value of this function I am going to evaluate at the given points 0, 1, minus 1, 0, 1, minus 1, 2, pi by 2, pi by 2, minus 1, 2. X equal to pi by 2, y square is minus 1, x is pi by 2, x is pi by 2, z cube is 2 cube, y is minus 1, z is 2, minus 4 here. Put x equal to 0, y equal to, means if you put x equal to 0, the sign 0 is 0 directly, right? If you put x equal to 0, it will be 0 directly. Minus 4, y is 1, 2z, z is minus 1. Now try to evaluate. This is sin pi by 2 is 1, minus 1 square is 1, I am writing 1, plus 8 by 4 is what, 4 pi, plus 4 here, minus 4 minus 4 is minus 6. This is equal to 4 pi, this is 9 plus 6 is 15. Work done in units. Force F bar is conservative. Why it is conservative? Because we have written F bar dot dr bar as an integral of d of scalar point function. Integral of d of scalar point function. That's why the force field is conservative. It means that the work done is independent of the path. Means either particle is being moved from this point to this point through C, through C1, through this AB straight line. This work done is independent of R. Therefore, F bar is conservative. Find the work done in moving a particle once round the ellipse, and equation of ellipse is given: x square by 16, y square by 9 is equal to 1 in the plane, z equal to 0. Z equal to 0 means xy plane. Under the force field given by Fr is equal to 3x minus 2y plus 2x plus 8yj plus y square. Find the work done moving the particle once round the ellipse. Then instead of this ellipse you will be given a circle. The work done is integral of Fr dot dr, and as we discussed, the Fr dot dr is what? 2x 3x minus 2y dx 2x plus 8y dy and y square dz, and this ellipse is in xy plane. In xy plane, the z component is 0. The sheet is xy plane, and where z component is 0, here z equal to 0 is the equation of xy plane. Therefore, dz is equal to 0. Here in the next step, put z equal to 0 and dz equal to 0, because we are solving problem in xy plane. Therefore, put z equal to 0 and z equal to dz equal to 0. If z is 0, put z equal to 0. 2x plus 8y dy, and dz is 0, no need to write. This work done, this line integral we are going to evaluate. The particle is being moved like this once round the ellipse. Particle is moving like this. Okay, this tip of the pen. Tip of the pen is moving, this particle is moving. Now solve this integral. When we evaluate line integral on closed continuous curve, ellipse, circle, or any other closed curve, then use parametric form. So what is parametric equation of the ellipse? In the denominator, equation of ellipse I am writing x square by a square plus y square by b square is equal to 1. This is standard equation of ellipse. Center is 0, 0 and period. Okay. Major and minor axis length we can find. When equation of ellipse is given, the x equal to a cos theta, a here 4 cos theta, and y equal to 3 sin theta. These are the parametric equation of the ellipse. This is a Cartesian equation. This is your parametric equation. Parametric equation you can easily write x equal to 4 cos theta and y equal to 3 sin theta. X equal to a cos theta and y equal to b sin theta. But when you evaluate integral, the dx is required. So here I am going to find out value of dx. Derivative of cos is minus sin. Value of dy is required. Derivative of sin is cos theta dθ. Put x equal to what? 4 cos theta. Y equal to 3 sin theta. Dx equal to minus 4 sin theta d theta plus 2x. X equal to 4 cos theta and y is equal to sin theta and dy is 3 cos theta d theta. For closed curve, ellipse, circle, use parametric equation. Try to solve. See, line integral over C. So you can directly solve. You can directly write the step down. Here, d theta I am taking on. This is d theta I have taken it outside. Now, here, product of this multiplied by this is 12 minus 4, 12 into minus 4, minus 48 cos theta into sin theta, product of this two. Then minus minus plus minus 6 into minus 4, 24 sin square theta. If this multiplied by this is 8 into 3, 24 cos square theta, cos into cos. And here 8 into 3, 24 multiplied by 3, 72 sin theta cos theta. For integral 72 sin theta cos theta, 48 sin theta cos theta, it is 24 sin theta cos theta plus 24 is common here, sin square theta plus cos square theta d theta. Now integral 0 to 2 pi I am taking. Okay, you can put here also because the particle is being moved like this. Theta varies from 0 to 2 pi. 24 sin and cos. Here, integral I am separating 0 to 2 pi. 24 d theta. Sin square theta plus cos square theta is 1. And I have separated integral sign. Okay. Integration is from 0 to 2 pi. The integration of sin theta into cos theta is 0. Plus this 24. Integral of 1 with respect to theta is theta. 0 to 2 pi. 24. Put theta equal to 2 pi upper limit, put theta equal to 0. And it is about 48 pi. It is a work done in moving a particle once round the ellipse in a place z equal to 0 that is 0, and the force field is always 0. Next problem, find the work done in moving a particle along x equal to a cos theta, comma y equal to a sin theta. Here, the question is here about C. Only the curve is changed, f bar value is changed. Find the work done in moving a particle along this circle. This is the equation of circle. And the equation of circle is given in terms of parameter. X equal to a cos theta, y equal to a sin theta. In examination, x equal to a cos theta plus y equal to a sin theta can be replaced by like this also. In examination, you will be given like this also. even value of a may be different also. Means x square plus y square is 1, x square plus y square is 4, x square plus y square is 9, like that. Find the work done in moving a particle along this circle. X equal to a cos theta, y equal to a sin theta, and z equal to b theta. From theta equal to pi by 4 to theta equal to pi by 2. Here, the important thing is that the limit is given to you, value of theta is directly given to you. Okay. Find the work done in moving a particle along this curve. Okay, because one additional thing is there. Zx equal to a cos theta, y equal to a sin theta, and z equal to b theta in the equation of curve. If only these two things are given, then it is the equation of circle. If these three things are there, then equation of curve from this point to this point. On the force field given by Fy equals minus 3a sin square theta into cos theta I plus a 2 sin theta minus 3 sin cube theta j I am writing here plus b sin 2 theta k. We solve this problem in the next lecture.